Hi, welcome to the lecture. Dave Soriano, chemistry professor, University of Pittsburgh's Bradford campus in Western PA. This small lecture is from a course I teach, Introduction to Biomass Fuels. And the topic here would be ethanol. Is ethanol? And certainly one of the liquid biofuels that comes to mind. So let us begin. The information that I'm providing you with is from Biofuels for Transport, and this is put out by the World Watch Institute, ISBN number 978-1-84407-422-8, 2007. Current status of the biofuels industry and market. And from this report, we find that ethanol and biodiesel are the two most widely used liquid biofuels for transportation today. Ethanol from sugar starch crops and biodiesel from vegetable oil or animal fats can be considered. Ethanol is blended with gasoline right now as an oxygenate, and biodiesel with petro-diesel. Ethanol is currently 86% of the total biofuel production globally. 1/4 for alcohol consumption or chemical utility, and the rest becomes fuel for motor vehicles. Most biodiesel is used for transportation. A small amount is used for heating. Between 2001 and 2006, global fuel ethanol production more than doubled, and biodiesel production increased more than sixfold. The oil market, same time period, increased by 10%. History of biofuel production programs. As early as the 1820s, American inventor Morey used ethanol in combustion engines. Otto considered ethanol with his spark ignition engines, and Rudolf Diesel first proposed using the engine on running it on peanut oil fuel. Henry Ford proposed ethanol as fuel, but cheap petroleum fuels flooded the market due to the business activities of J.D. Rockefeller. More biofuel was used during World War II, but the 1970s oil crisis prompted countries to seek alternatives to imported oil. Brazil, as early as the 1970s, expedited bioethanol program, and by the 1980s, 60% of fuel in cars was ethanol. The United States, 1980 saw the use of corn to make bioethanol. The USA and Brazil still account for 90% of bioethanol market in the year 2005. The European Union, 1992, agreed to confine oilseeds market to just under 5 million hectares, that's about 2.5 acres, due to a trade dispute which triggered a rise in biodiesel production. Now, the methyl t-butyl ether, MTBE, has been phased out as a gasoline oxygenate, and as a result, the only other material, to the best of my knowledge, being used right now in gasoline formulations is ethanol. Brazil, flexible fuel vehicles, FFVs, which can run on any combination of gasoline and ethanol. More than 75% of new cars sold are of this type in Brazil, and ethanol production has increased substantially. World biodiesel production. Germany, 40% of the world share, the United States 14%, mostly from soybean, France 10%, and Italy 9%. Recent developments in the biofuel industry. Countries wishing to boost agricultural industry have coupled to those concerned about oil politics, greenhouse gas production, gas emissions, urban pollution, etc. Recent R&D has brought new interest to biofuels. Ethanol from cellulose and the conversion of the latter to a range of liquid biofuels is being considered. An example of a liquid biofuel is a conversion system that uses high temperatures, low oxygen to convert solid biomass into combustible gases, which can be coupled to a gas-to-liquids conversion process, better known as Fischer-Tropsch process, to produce liquid fuels. Daimler-Chrysler, Volkswagen and Shell have collaborated to make a marketable version of this technology. Canada, U.S. Governments have supported groundbreaking research into enzymes that can refine abundant, low-value plant fibers into ethanol. Novozymes, in the year 2005, announced that costs of the required enzymes can be reduced 10 to 30 times. Ethanol from sugars and starches, a primer. Ethyl t-butyl ether and lipid-derived biofuels, straight vegetable oil, and biodiesel. Carbohydrate-derived biofuels. Ethanol from sugars, sugarcane stalks, sugar beet tubers, sweet sorghum stalks, all have a large percentage of fermentable sugars. Starch crops such as corn, wheat, and cassava, tapioca, can also be hydrolyzed to fermentable sugars easily. Cassava, tapioca, can be grown wherever people live in Africa, in the continent of Africa. Wherever they live, you can consider that tapioca can be grown as a cash crop, a food and a fuel, transportation fuel. With low oxygen conditions, the plant sugars naturally ferment into acids and alcohols, ethanol fermentation process, over time. And yeast has been used by humans for thousands of years to do this. Ethanol production is started by grinding up the feedstock so that it is more easily processed. The ground material is then dissolved in water, or the starch is converted into sugar. Yeast reacts with the fermentables in a closed anaerobic chamber, and yeast enzymes metabolize the sugars into ethanol, lactic acid, hydrogen, and carbon dioxide. Some other alcohols are produced too, small amounts of methanol and the amyl alcohols called fossil fuels, fusel oil. Brazilian facilities are the most significant producers of sugar-based ethanol fuel in the world. The fermentation units are located near the sugar mills where refined sugar, molasses, carbon dioxide, and fibrous residue from stalks, bagasse, are produced. The bagasse is used as a boiler fuel to produce steam for heat electricity needed for fermentation, and excess is sold to the power grid. Even after thousands of years doing fermentation, humans have improved the process by conducting continuous fermentation by recycling yeast before the alcohol levels of typically 10 to 14% kills them. Ethanol from starches. Corn, wheat, and cassava have high starch content, and saccharification requires hydrolysis, which involves more time and energy cost in production. This must be kept in mind. Two methods are used in processing the starch. A wet milling treatment with sulfurous acid to separate starch from protein, and B, starch-rich seeds are ground into small particles called dry milling. The milling processes produce corn oil, gluten feed, germ oil, starches, dextrin, and sweeteners such as high-fructose corn syrup. All new mills being built in the United States are dry milling type since the process is cheaper and faster. Keep in mind that wet milling does offer flexibility and diversity. The CO2 produced during fermentation is often sold to the carbonated beverage industry. Ethanol distillation. The 180 proof ethanol produced from fermentation is dehydrated to bring it up to 190, 200 proof. Please keep in mind that proof is twice the alcohol content by volume. So if you have a 25% solution of ethanol and water, the proof of that solution is 50 proof, twice 25. Ethanol blended with gasoline must have less than 1% water present. Neat ethanol, warm weather climates, can have up to 4% water. Brazil, since freezing conditions do not occur. Ethanol as fuel. 1 liter of ethanol has about 2/3 the energy of a liter of gasoline. It has very high octane level, anti-knock, to prevent premature combustion of the fuel in the engine cylinder. Since ethanol has oxygen in the formula, it is called an oxygenate. This helps to improve the fuel combustion process, cutting down on carbon monoxide, ozone-forming unburned hydrocarbons, and polyaromatic hydrocarbons. Ethanol combustion can react with atmospheric nitrogen to form nitrogen oxide gases. Ethanol has far less sulfur than gasoline, so sulfur oxide gases, that's not a problem with ethanol. Carbon footprint is far smaller than gasoline since it is a product of fermentation using atmospheric CO2. Ethanol has high solvent properties, which, however, can corrode certain types of metal, rubber, and plastics, the latter used in hoses and gaskets. Water contamination of ethanol gasoline can cause a phase separation to occur, and also blending even small amounts of ethanol and gasoline can raise the fuel's vapor pressure, affecting engine performance and contributing to ozone emissions. ETBE. You can react ethanol with isobutylene gas to produce ethyl t-butyl ether, A typical 15% solution in gasoline has a biofuels content of 6.3% by volume. However, the isobutylene is coming from fossil fuel, which reduces ethanol displacement of gasoline. ETBE has the same cancer-causing properties as MTBE, but is less soluble in groundwater and may disperse less and be easier to clean up when spills occur. ETBE does not raise the fuel vapor pressure of gasoline blends. It's more soluble and will not phase separate. These are important points, and many European fuel companies have promoted the ETBE. Lipid-derived biofuels, straight vegetable oil, SVO. This can be extracted from nearly any oilseed crop such as rapeseed, canola, sunflower, soybean, palm, corn, etc., and can be used in diesel engines. Used cooking oils from restaurants and animal fat from slaughterhouses, those are also potential feedstocks for use in diesel fuel applications. After filtering out particles and removing water, this purified biomass-derived oil can be burned directly in some combustion engines directly, depending on the the injector and other parameters. Oils are usually extracted from plant seeds by first cutting them into flakes and then immersing in a chemical solvent. Hydraulic crushers are too energy intensive. The non-oil seed components are often sold as high-protein meal for animal feed or used as fertilizer. Due to viscosity differences compared to petro-diesel, SVO, especially at colder temperatures, must be heated, engine refitting, or the engines must be dedicated, such as the Elsbeth engine. Modern diesel engines with increased electronic ignition combustion control systems are generally not acceptable with straight vegetable oil. Coconut oil with shorter chains can be used directly with petro-diesel in modified engines in tropical locations, where oil will not thicken in the warm weather. Biodiesel, less viscous transesterification product derived from vegetable oil animal fat. 80 to 90% oil, 10 to 20% alcohol, methanol. Acid or base catalyst, usually base catalysis is used. It's perhaps 1,000 times faster. With methanol, 55 degrees, right at the boiling point of methanol, 2 to 3 hours. I've seen papers and patents coming out where it can be done far less time now, even at room temperature. You separate the glycerol from the product, and 88 to 95% as much energy content in biodiesel versus the starting oil. Biodiesel blends are sensitive to cold weather and need additives. A B20 biodiesel formulation is usually used in the United States. You'll see it at the diesel pumps. Production costs for biofuels. Biofuels have almost always been more expensive than petrofuels. Above $35 a barrel U.S., sugarcane ethanol made in Brazil is competitive. Corn-based ethanol in the United States is competitive above $55 a barrel of crude. What are we running now when I make this lecture? About $95 to $100 a barrel in the United States. Government tax credits can make biofuels seem cheaper than they really are. First-generation feedstocks. These are materials that are harvested for sugar, starch, and oil content and can be converted into biofuels using conventional technology. Next-generation biomass, this is harvested for total biomass and can only be converted into liquid biofuels using advanced technical processes. Where countries have fostered biofuels development, the primary impetus has been to support the agricultural sector. Currently, only a relatively few crops have provided the vast majority of the world's ethanol biodiesel fuels. In Europe, most biodiesel comes from rapeseed, canola in Canada, U.S. ethanol from corn, soybean for biodiesel, and Brazil uses sugar cane for ethanol. A key variable is the amount of biofuel that can be produced per hectare. Sugarcane, the most significant crop for biofuel in the world today. Most comes from the center-south part of Brazil, also Australia, China, Indonesia, Pakistan, South Africa, and Thailand all produce ethanol with this crop to some degree. Recently, about 50% of Brazil's sugarcane crop goes to ethanol production. Sugarcane stalks have so much sugarcane content that it is the lowest cost source of biofuel. Cane plants also produce a significant amount of fiber that can be converted to ethanol as well. Sugar beets, important source of sugar in Europe and a valuable feedstock for biofuel in France. Worldwide, the annual production of this crop is shrinking. Sugar beets are generating good yields in temperate climates, but are much more chemical energy intensive to work with. Sugar beets, because of concern about pests in the soil, cannot be grown more than once every 3 years in the same soil, and yields depend on climate conditions. Sweet sorghum, a multi-use crop where seeds can be eaten and sugars and stalk used for fuel. It can be grown in temperate climates. This concludes part 1 of the lecture. Please continue along with part 2. Thank you.